be using L'Hopital's rule, but you won't be able to launch into it right away. There's going to be some manipulation you need to do first. So we're going to talk about the two easier ones first. And that is when your direct substitution, like you go, this is by the way from the right. That little plus sign kind of came up. Understand why that has to be there. And the natural logs pops up a lot in today's lesson, so it's kind of important you know what the graph of y equals the natural log of x looks like. In particular, what the end behavior is. So like as you approach 0 from the right-hand side, what would you tell me the natural log of x approaches? Negative infinity. Yeah. X squared would approach 0. So this ends up being 0, technically times negative infinity on direct substitution. That is an indeterminate form, but it's not one that you can use L'Hopital's rule for. Go put a little plus or minus there. Like I told you yesterday, I have a hard time typing those in. So when direct substitution yields that, this is 0 times negative infinity. This would be 0 times 1 over 0. And what do you think I want you to consider any number over 0 technically equally? How many zeros fit into 5? An infinite amount, correct? So you're to consider that 1 over 0 infinity. So technically, all right, over here too, we'd have 0 and cotangent. We'll talk about it in just a second. But all of these are going to lead to 0 times one of the infinities. When that happens, you are just going to rewrite. So you're just going to do a little rewrite, because products can be written, all products can be written as a single fraction. For example, I could say 2 times 3 is actually the same as 3 divided by 1 over 2. Would you agree that's the exact same thing? Right? So you're going to take and write your products as a single fraction. Sometimes you're going to have an option for how you want to do that. I would kind of say go with your gut. And I'll talk about that when we get there. So it says to get in this form. So this right now is a product of these two, and it's an indeterminate form, but it's not a L'Hopital one. But once we can get it like that, we can L'Hopital. So when you see these products, you are going to say, all right, I'm just going to take and do a little rewrite on this guy. So these aren't too bad, because they're easy to spot. So whenever you get 0 times the infinities, you're just going to stop and rewrite it so that you either get 0 over 0 or infinity over infinity. I like to take the more complicated function and leave it on top as it is. I don't have to, though, if we go either way. What do you think I'll have to divide it by then? 1 over x squared. Those are identical, but watch how the indeterminate form has changed. Natural log, as I approach 0 from the right, goes to negative infinity, correct? And on the bottom, what happens to 1 over x squared as I approach 0 from the right? It goes to infinity. Yeah, it's 1 over 0.00000001. It's going to go to infinity. So this guy is going to give me this indeterminate form. On your key, you're going to see me star it once I get it L'Hopital worthy. So that means once I get it 0 over 0 or plus or minus the infinities over the infinities, I know I can launch into L'Hopital's rule. I didn't star this indeterminate form. I wrote it down, but I'm like, that's not one I can work with yet. Now you're going to tell me that you're launching into L'Hopital's rule. You can just put LH and I'll know. Sometimes you'll be launching into it twice within a problem. You'll be like, oh, all right, oh shoot, now I have 0 over 0, I gotta do it again. So I'm gonna go do L'Hopital's rule. It's still a limit. I'm touching the board too much, sorry. It's still a limit as x is approaching 0 from the right. The derivative of the top, 1 over x. Again, remember if that was the natural log of a function of x, it's u prime over u. So there's lots of derivatives in here, lots of understanding of infinity, L'Hopital's rule, there's all kinds of stuff going on. I'm going to scroll a little bit here. What's the derivative of 1 over x squared? Negative 2 over x cubed. Yeah, it's x to the negative, so just make sure you've got your derivatives down. Okay, so it'd be negative 2 over x cubed. Then I'm going to clean it up. I'm just going to keep on working with this until I can get at an answer. When I multiply by a reciprocal, so you might want to write yourself a note that that's what I'm going to do. But when I multiply by the reciprocal of the denominator, I will end up with what, an x squared on the top, right? Over negative 2, is that right? X squared over negative 2. Now I've arrived at an answer. What's my answer? 0. And I am done. Okay? So very straightforward for this one. All I did was realize I had a product. I wrote it as a quotient so I could get either one of those two forms so I could go to L'Hopital's rule. So let's go to the next one. If this one was on your worksheet, you'll go, this one's not too bad probably because I just need to rewrite it so that I can work with a quotient. Which one do you think I'm going to choose to keep on top? Sign, yeah. Just I'm giving you little helpful hints. They're not must-dos. But I don't really want to do one over that and end up with some sort of cosecant and have a mess. So I'd rather do this. Now, I want you to look at that and tell me what indeterminate form you got. I don't want you just guessing that you have one, because sometimes you don't. So if I think of sine of 1 over infinity, what number am I really taking the sine of? 0. And what sine of 0? 0. And on the bottom, what's 1 over infinity going to go to? 0. I will circle that, and on your key, you'll see me start. Do you remember why I said I do that on the key? That's the one that allows me to do what? L'Hopital. Yeah. Now, I hit it right away on these, but there's some others where I won't. So I'm going to tell my AP reader / Mrs. LaRue to tell me that I am launching into L'Hopital's rule right now because I got that indeterminate form. So I'm going to take the derivative of the top. All right. So what's the derivative of sine? So I'm going to have a cosine 1 over x, right? Times the derivative of 1 over x, which is what? Negative 1 over x squared. And lots of derivative taking, so that's going to be rock solid. And then I need to divide it by the derivative of the bottom, which is also, yeah. So this one falls out nicely because what happens? Canceling. Yeah, so when I cancel this off, you guys are listening. So this is level, there's 3 levels. This is level 1, okay? Of the hard ones, though. So, okay, now I'm ending up with this limit as x approaches infinity of cosine of 1 over x. Is that able to be evaluated? It should be. Because what will 1 over x approach as x goes to infinity? 0. So what will cosine approach? 1. Yeah, cosine 0 is 1, and I've arrived at a really nice answer. So far so good, right? Okay. The next one, that's an alpha right there. Again, I purposely kind of messed with some of the variables because that can kind of throw you for a loop. If you do decide to go to x, because you're like, I don't want to deal with alpha, I don't want to deal with y, then make sure your answer goes back to alpha. All right? So if you want to change it to x now and go back, or leave it? Let's leave it so you get used to it. All right. So right now, when I plug in an alpha, I have 0 times. And technically, cotangent is what? You give me 2 answers for this. Cosine over sine, or you could tell me it's 1 over tangent. Okay? Either way, I want you to kind of think about what that would be. 1 over tangent twice 0. What's tangent of 0? Sine, it's 0. And what do you think I want you to think of 1 divided by 0 as being? No longer really undefined, because how many zeros fit into 1 when I go 0 plus 0 plus 0 plus 0 plus 0? Infinity. Yeah, so you're going to picture this as being 1 divided by 0, which is infinity. So I do have this product of 0 and 1 of the infinities. Now you have to make a decision. And I'm going to give you a little, I already told you over here, deal with the more complicated function usually. Another thing is, I don't like cotangent, I don't like cosecant, and I don't like secant. Do you guys? Which ones are more user-friendly? Sine, cosine, tangent, correct? I would go to them as soon as possible. So I'm going to show you this one 2 ways. So suppose Alexa's like, I remember LaRue saying she doesn't like cotangent, and she goes, I'm going to replace it with 1 over tangent. Is that legal? And let's see if it leads her to something that's helpful. So now take a look at when I plug the 0 in. What would I have on top? 0. What would I have on bottom? tangent of 0, which is what? 0. Yes, this would be great. If Alexa decided to do that, she's going, yes, that was a good choice. And you're going to see me do that on a key just like that. Why is that such a good choice? What can I do right now? L'Hopital. I now have a fraction that resulted in a L'Hopital-worthy indeterminate form. That sounds weird, but I'm going to tell that I'm watching right now. And I'm going to do limit as alpha approaches 0. What is the derivative of alpha? Seems kind of weird to ask, but it's like the derivative of x. 1. What's the derivative of tangent? Secant squared, but you gotta be careful because it's secant squared times 2. Excellent. Little chain rule in there. So a ton of stuff going on here. Anyone walking in from the hallway wouldn't have a clue what this is. Like literally anybody in the building would know what is going on there. So if you can understand it, that's pretty impressive. So now I'm going to do a direct substitution and see what I get. The top is a 1, right? On the bottom, what is secant squared of technically 0? You think, well, it's 1 over cosine squared 0. What's cosine 0? 1, right? So now we got trig going everywhere. So all of this is 1. Go ahead and bracket it up, and that'd be at a 2. And I'm all done. But I said that because that's what Alexa said she was going to do. I pretended. That she decided that she was going to get rid of cotangent going to tangent, right? But perhaps Rafe says, you don't write this down, just watch. He takes a different route. He still has alpha approaches 0, but he has it in his head that I said I like cosine, sines, and tangents. So he changes his to what? Cosine 2 alpha over what? Sine 2 alpha. His work looks very different than Alexa's, but both of them still now have a 0 over 0. Do you see it? 0 and a 0 on the bottom. He can also launch into L'Hopital's rule right now. It just won't be as pretty, but you don't know that. So sometimes it's just luck of the draw. Because on the top, what rule would he have to use? It's like x cosine 2x. Product rule. Yeah, you'd have to go first d second plus second d first. And on the bottom, what is the derivative of sine 2x? Cosine 2x times what? 2. But when you're all done, guess what he would get? I'm not going to do it. A half, if you did it correctly. So the second
You know
option...
me too well. I like expanding everything.
Yes. So doing it either way... Yeah, we'll have to do that. Okay, sorry. I know I told you to come in. I forgot. Yeah, sorry. I forgot why I was doing such a complicated thing today. All right. So this next one says you try, but I actually, just to save time, I think we're going to take it, have at it together. All right? So first of all, when I plug in infinity, y will go to infinity. So I do have infinity. What does this go to? Natural log of y plus 1 over y minus 1 as y goes to infinity. 0. Right, because what will the guts of this go to? 1, right? The coefficients are tied. Then what's natural log of 1? This is this guy again, where it's like, uh-oh. So you are going to take and do a rewrite. We'll do it kind of quickly here. I think you've got this kind of down. Which one do you think I'm going to keep on the top? I don't have to, but I kind of don't want to flip the natural log of... So I'm going to keep the uglier piece on the top. Usually is much better. What am I going to put on the bottom? Just make sure we're good. Well, there we go. 1 over 1. Okay. I'm now sitting there with the natural log of 1, technically, right? As y goes to infinity, this goes to 1. Natural log of 1 is 0, so I am good with that. On the bottom, 1 over infinity is also 0. I go, yay, L'Hopital starts right now. But then you got to be careful when you L'Hopital, because look at that top of the fraction. So I'm going to go real slow with this because I'm going to kind of flip and multiply as I go. But how do you do the derivative of the natural log of u? U prime, right? But to do u prime, what rule do I need? Quotients. See all the calculus in here? It's like loaded. So we are going to do the quotient rule on this to get u prime. We're going to do low, d high, which is 1, minus high, d low, which is also 1. We're going to square a line, or draw a line, and square below. That is only u prime. Everybody okay with that? Am I going too fast? We're good? That's only u prime. And what is the derivative of the natural log of a function of u again? It is what? U prime over u. I haven't put it over u yet. But instead of putting it over this, I'm going to multiply it by what? Reciprocal. There we go. So I'm just trying to keep it so it's not so complex fracturing. That right there is u prime over u. Now I needed to divide it by the derivative of the phi. You good with that? What's the derivative of 1 over y? Negative 1 over what? Y squared. But instead of dividing by that, can I understand what I mean? I said you need to bring your brain today because I'm going to multiply by negative y squared over 1. I just don't like a fraction over a fraction over a fraction over a fraction. So do you understand the method of my madness? Now I'm going to go clean this up. All of this, the y's would cancel. Looks like I'd have negative 1 minus 1. So I'm going to cross this off to save us some time. That whole bit is a negative 2. So there's partial cleanup. What can I cancel also? There's a y minus 1 right here. That's going to wipe out one of these. So I'm going to put another one down there. And it looks like now I've got to do a rewrite. So your notes just became kind of messy. That's why I say it's kind of more the listening today. All right, so on the top, it looks like all I have left is a 2y squared. And it's positive. And then on the bottom, I have this. You should actually know what this limit is. Pretend y is x, because sometimes we don't like variable changes. And pretend it was 2x squared over x squared minus 1. What's its limit? You should know. Because as we go to infinity, it's all about the highest powers. The highest powers are tied. Correct? So 2. Agreed? The reason we don't see it so quickly is because there was a variable change here. So in your head, you might want to go 2x squared over x squared, and I don't care what the rest is. This would be a 2. We're going to take 1 second, show you the graph of that sucker so you can see it, have a visual, and we're going to the next thing. All right? So just so you have a visual, I'm going to pop up here on Desmos. And the cotangent one that we got to be a half is this red one. So that was that alpha cotangent to alpha. Do you see how it's up here at a half, and that's what we got? The other one that we just dealt with is this natural log one, and we were approaching infinity, and we got 2. Does that look pretty good? Yep, so kind of realize what you're finding. Next up, I would actually say this one isn't harder. This is easier than that last kind, okay? And then we'll get to the hard ones, all right? So when you have this indeterminate form, where you have infinity minus infinity, and you might say, why is secant, as I approach pi over halves, why would that be infinity? It's 1 over cosine, and what's cosine pi over 2? 0, and what did I tell you? I want you to think of any number over 0 as being infinity, okay? So this guy is infinity. It's approaching infinity. Now I put an alpha there. It's approaching infinity, and the tangent graph, it's good to know the tangent graph too, because that pops up this chapter. Do you remember what it looks like from? Yeah, it looks like this. It's periodic, so it keeps doing it over and over again. But as I approach pi halves, let's say from the right-hand side, there should be a little direction there. That's also going up forever. So I have, but the key to this is you see the subtraction. And you can't work with subtraction, you can only work with division. Okay? So what you're going to do is get an LCD. I told you I don't like secants. What did I tell you I would consider it? 1 over what? So trig back in full force. What do you think I'd write tangent as? Sine over cosine. Perfect. Okay? So I'm going to get rid of my subtraction by getting an LCD. minus sine x over cosine x. Let's see if I'm ready to launch L'Hopital's rule. So I have to stand back. What's sine of pi over 2? 1, right? 1 minus 1, I have a 0 on the top. And what's cosine pi over 2? 0. You need to know that unit circle, but this is ready for a L'Hopital. And I know you know how to L'Hopital, so can I just go dot, dot, dot? This was all about just getting it to what you already know how to do. So I'm going to go L'Hopital, and I'm going to go dot, 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 just so I can get to the third level. So anticipate what I'm going to do on this guy. Technically, I have 1 over 0, because e to the 0 is 1. I want you to think of that as infinity. Minus 1 over 0, which I also want you to think of as what? Infinity. So this is this indeterminate form. Not L'Hopital worthy. You see the subtraction, and you're going to go, oh, common denominator. How did I teach you in Calc AB to clean that kind of up? Yeah, there you go. Crisscross, multiply across. So you're going to go x on the criss minus, and then it'd be e to the x minus 1. And then you're going to multiply across on the bottom. Alright, so I'm getting a single fraction right there. I'll clean it up. So let me clean up the top of it anyway. I would have x minus e to the x, watch my arithmetic too, plus 1 over x e to the x minus 1. What do I do next? I plug the 0, and I hope I can L'Hopital it. Can I? What does the top go to? 0, right? It'd be 0 minus 1 plus 1. The bottom also goes to 0. So I'm going to go, oh sweet, 0 over 0 L'Hopital. But something happens with this one, so I'm going to take this one a little bit farther. So when I L'Hopital it, I'm going to do 1 minus e to the x over, what rule do I have to use on the bottom? Product. So I got first d second minus second, and then d first is 1. Now look at what you end up with. Are you ready? So I'm going to dot, dot, dot here pretty soon. But what will I have on the top? 1 minus 1. What's on the top? 0. Look what's on the bottom. 0 minus 0. What do I still have? Why would you go, what do you have to do? Again. Yep, so it's possible you have to do more than one iteration. So I'm going to go like this. I'm going to go L'Hopital, because I'm not teaching you the standard L'Hopital. Alright. Now it's going to get a little complicated. Were you good on those two, though? Those are pretty straightforward. Now it's these other guys. The first one was when we had infinity times zeros. The second one was when we were subtracting them. This is when we're raising to a power. And there's some stuff that you need to remember from other parts of our class in pre-calc. First of all, limits are super what I call malleable. For example, watch. The limit as x approaches 2 of the square root of x plus 7. What is it? Go ahead, just tell me. What is that? 3, correct? Limits can also go inside of functions and you get the same answer. So I could do the root first of this limit. Those are the exact same thing. What do I get on the bottom one if I do the limit as x approaches 2 of x plus 7? I get a 9. Right? What do I get when I root it? 3. They get to go in roots, into functions, into powers, and more importantly, what we're going to be doing is taking limits. I'm going to say as x approaches 3, I'm going to say the natural log, and I'm going to say of x minus 2. What's the answer to that? It's easy. 0. It's the limit, right? And I plug the 3 in, I'm taking the natural log of 1, and what is it? 0. But they can be swapped. I can do the natural log first. And then I could do it of the limit as x approaches 3 of x minus 2. These limits are super forgiving. They can go in and out and up into exponents. When I do this, I would do my limit first, and I would get 1, and then I take the natural log. For both of these, though, I get 0. You agree? Right? So we're going to do some moving around natural logs or taking them out. It's legal. Next, you're going to have variables and exponents. So you have to remember from pre-calculus how you get them out. Like if you were solving this in pre-calc, what would your teacher said to do? Like I don't know what x is. What do you do to get out of that exponent? You know? What did you say? I think I saw you. Yes. You natural log both sides. Keep in mind why. There's a property of logarithms that says what can you do with exponents? Take them out front, correct? So this would become natural log of 5 is equal to x minus 3, you might want to draw an arrow, times the natural log of 2. So if your unknown is in an exponent, you really want to get it out. How are we going to do that? Natural log, okay? So in our next examples here, you're going to see the trigger for this. Go ahead and kind of point at that. I've got a variable and an exponent. You're going to go, oh no, those are the hard ones, right? Going. Yeah, it's still going. All right, so go to the next page, and you're going to see that same trigger on those bottom two. I might not get to all of them today, but variable in the exponent, variable in the exponent. So are they easy to spot? The minute you see that, you're going to think, I need to do this natural log process. That's going to trigger it for you. But I have to talk about what it is first. So we're going to go down below here and talk one through really slowly. So it starts on the bottom of this page. We are supposed to find the limit as x approaches infinity of. Now watch. The first thing we're going to do is we're going to define this as a function. We're going to write y equals. So your limit is sitting there. We're going to call it y. And you're going to go take a look and say, well, this would be infinity to the 1 over infinity. What is that? 0. That's one of those three I just said. And this is not good. Here's how it starts. You're going to take the natural log of both sides. What would have triggered this? You saw a variable in the exponent. So you're going to go natural log of the limit as x approaches infinity of x to the 1 over x. So the first thing, natural logging. Good so far? Yes? Okay. The next thing is I'm going to use the fact that limits are malleable, and I'm going to bring my natural log in and my limit out so I can get that exponent out of there. So I want you to kind of go maybe like that so you know what we're doing. Limits can be interchanged in functions. Okay, so we're going to go to the next page, and we're going to do a little rewrite of that. I would have the natural log of y is equal to the limit, right? What was I approaching on that one? Infinity. As x approaches infinity, and it would be the natural log, and was it x to the 1 over x? Yeah. All right, of x to the 1 over x. How are we doing now? We good? Next step, this can now come out front. So I'm just going to keep working on the right-hand side here, and I'm going to say, all right, this would be 1 over x, natural log of x. It's now a product. Would you agree? It's kind of back to phase 1. I could easily get this so that I could L'Hopital it if I just rewrote it like that. What do you think about why? Kristen, how are you doing? Are we good? There's a little rewrite there. They're identical. What form is this guy now in? What's the natural log as I approach infinity of infinity? Where am I going? Infinity. Where's x going as I go to infinity? If this is one of those two, where you go sweet, and on my key you're going to see a little star, and what always comes after the star? L'Hopital. Oh, you guys are listening. Good. So I'm going to write a little LH above my equals, and I'm going to go L'Hopital this. Natural log of x is 1 over x. Its derivative. And the derivative of x is just 1. And we're done. Because now what do I get as I approach infinity? What will this limit approach? 1 over infinity is what? This is where you have to be really careful. That's not the answer. Just go right here. We natural logged to start this problem. This is what the natural log of our answer is. So you need to undo it. How do you undo natural log? B. Yeah, you exponentiate. You do e to the ln1, which is just y, and you do e to the 0. And what is that? 1. Do you think a lot of people forget to do that? So you natural log to start it. We natural log so we can get that out of the exponent, but when we're done, we have to undo it. On that one go. How are we doing? Doing okay, Owen? All right. We got another one. All right. I can't do a ton of them. I have 3 here, but here's my next one. Are you ready? Let's see if you got the algorithm down. This one's actually got huge historical importance. So, that I'll explain maybe on another day, and I'll give it as an ELF type like bonus for you to kind of redo it. But right here, we're gonna start. You're gonna go, okay, I've got 1 plus, and then technically I have 1 over infinity, which is 0. I have 1 to the infinity sitting here. Do you agree with me? Yes? I don't like that. But my variable's in the exponent, so I'm going to start by going like this. Now let's see if you remember. I only did 1. Try not to look at the steps. What am I going to do right now? Natural log. I'm going to natural log both sides. Now, I'm going to go natural log of y is equal to, you might want to swap, just to save yourself some space, everybody watch. Like, so you're not writing as much. You might want to swap your limit and your natural log as you write it. Okay? So you might want to write, instead of natural log of the limit, you might want to write limit as x approaches infinity of, and then it'd be the natural log of 1 plus 1 over x. But instead of putting to the x, what might you want to do? Just so you're not writing so much. So you might want to do the swap and what with the power all in one step. Bring it out. You don't have to, but I kind of think it's wise. All right, so I'm going to do a little rewrite here just to clean it up. So I have a little limit as x approaches infinity of x times natural log of 1 plus 1 over x. Now I have to go back to how we started. What did we do when we had a product? I can't L'Hopital this yet. I'm not ready to roll. I do have an indeterminate form. I have infinity times 0, but that's not worthy. So what do I do when I have a product? Now I go back to phase 1, like how we started the hour. What'd you say, Krista? Yeah, I need to write it as a quotient. Which one do you think I'm going to put in the denominator, just based on the fact that you guys have been listening? The x one, but how will I write it down there? Okay, all right. This is feeling good. All right. Now let's see what indeterminate form we have, because I give you 1 point for writing the correct one down. It's not going to make or break you, but it's kind of important that you don't just assume. So on the top, I'd have natural log of 1 plus 1 over infinity. Natural log of 1, basically, 0, right? On the bottom, 1 over infinity, which is what? So I'm going to have 0 over 0, and you're going to see that on my key, right? And what does that indicate on my key? I'm going to now launch into L'Hopital's rule. So here we go. I'm going to put a little LH above this. I'm going to take my limit. I'm going to have x approach infinity. Again, you got to be careful. How do you do the derivative of the natural log of u? U prime, okay? What is u prime? That's going to be on the top of my fraction. U prime would be negative 1 over x squared. What do I have to put it over? U. You only took care of the derivative of the top. Correct? So I'm talking really slow. What's the derivative of the bottom? I only took care of the derivative of the top. I did u prime, like Greta told me to do, over u. But now I need to put it over the derivative of the bottom. What's that? Negative 1 over x squared, right? So negative 1 over x squared. This is a complex fraction nightmare, but you should know what happens. Do you know what would be left in this? 1 over what? 1 plus 1 over x. Yeah, you got it. So this is the limit as x approaches infinity. These would cancel, and I'd have a 1 over 1 plus 1 over x. Be careful, because you're going to think you're done, right? What is that limit? That limit's going to be what? 1 over 1. Why is that not the answer? Exactly. I have to undo my little trick of natural logging both sides. This is what the natural log of y equals. So what's y? E. Interesting. This is one of the 3 accepted definitions of what the number e actually is. Have you ever used that formula in Algebra 2, PERT, P-E to the RT?
Yeah.
You don't remember that? P-E to the RT for compound interest?
Yeah.
Well, the derivation of that ends up having, you should have always wondered, how does some weird number e insert itself into our money? It's time that ends up going to infinity and you're compounding all the time, but this ends up in it. You end up getting the principal times this to the RT to replace this with an e, like in the person whoever came up with it. I will prove that for you, but not today. So last one up for today, I think, because I don't want to lose you, but this one's a good one. Are we ready? Say yes.
Yeah.
This one is currently 0 to the 0. Not good. But I've got my variable up in the exponent, so I'm like, this is that natural log kind. I need to natural log both sides. I need to see both sides. So that triggers the y equals. Now I'll see if you can write the next line by combining 2 steps at once. So you don't, on my key, I think I show more steps than you're going to. But that's just in case. Now look up here and see if you wrote it right. Are you ready? You should have done the natural log of y is equal to technically the natural log of this limit, but we're going to reverse them because it's legal. And we're going to do natural log of x, but instead of writing to the sine x, what am I going to do? Put it over here. How do we do? You good? Alright. Next step. This is now 0 times sine of 0, 0. What's the natural log of x as x approaches 0 from the right? Negative infinity. That's 0 times negative infinity. It's that product kind, which is kind of a mess. So I'm going to get it as a quotient. I'm just going to make the decision to keep natural log on the top because 1 over natural log is awkward to me. On the bottom, I'll do 1 over sine of x. Now let's see what we have here. Are you ready? What would the top go to? What's the top go to? Negative infinity. The bottom is going to go to 1 over sine 0, which I told you to think of 1 over 0, and think of it as being what? You're going to go sweep, score, star it, I get to L'Hopital. I want you to watch what happens on the bottom. Alright, so the derivative of the top, easy peasy, mac and cheesy, right? What's the derivative of the natural log of x? 1 over x. You have 2 options with the derivative of the bottom. You could have a good memory, which is fine if your memory's good, but knowing that this is cosecant and then having memorized what its derivative is fine. But it's easier if your memory faultier because we like sines and cosines anyway. Do you guys remember what the derivative of cosecant is? That's an antiderivative. So that's the, do you guys remember? And I taught you a way to remember it. I said, well, the derivative of secant is secant tangent, right? Negative cosecant. But most of us forget that. And then we have 2 that we don't like in there, correct? Because I don't like cosecant or cotangent. So I'm going to suggest you just kind of do the derivation of that. You quotient rule that right there. And it'll just keep it in terms of sine and cosine. You would do low, d high. What would you get? 0. So you go low d high, so you have 0, minus high d low. Negative cosine, correct? Draw a line and square below. If you were to break this up, you would get negative cosecant cotangent. You'd have a 1 over 6. But I would just leave it like that. What do you think I'd suggest you do now? I hate all that complex, right? Reciprocal. Yeah, exactly. I would definitely go and say, well, working on this is not very fun. I'm going to do 1 over x times, and then I have a sine squared on the top, right? And a cosine on the bottom, and I need a negative somewhere else over here. Unfortunately, why do I say unfortunately? I don't get infinity. I get what? What's on the top? 0, right? Sine squared 0, 0. What's on the bottom? 0. But that's okay. I just need to what? Do it again. No. Okay. But it's not. Yeah. Alright, so here I go. I'm still taking my limit. I have to L'Hopital because I got an indeterminate form. My infinity to infinity cleaned up to 0 over 0. But watch my derivative's fairly nice. What's the derivative of sine squared? 2 sine x cosine x, right? And then a negative over it. What do you think I have to use on the bottom? Product rule. Very good. First, d second plus second, and then d first is 1. Okay, look at what you get. What's my new top? 0, because sine 0, 0. My new bottom would be 0 plus 1. I got 0 over 1. That is a number. What is the number? 0. So if you get excited and say the answer is 0, you're so close. What's the actual answer? 1. Yeah, that's what the natural log of y equals. So e to the 0. Wow, right?
All this stuff. And
Woo!
then say, okay.
All right.
And you got 0.
We're gonna put
0.
zero.
And 10. And then not tell them all about it. I don't like have them forget about the L and just be like, oh, you got 0?
Imagine giving this to
Alright, so we're gonna have a little chat on these for a second. Infinity plus infinity is infinity.
Let's have an AV person come in here.
Alright guys, so
I think that would be very funny.
this sucker ebbs and flows. Like actually, I'm gonna tell you the first 4 are pretty hard. Look at them and tell me why. The supernatural law. Yes. Yes. I'm gonna tell you 5 is really easy. If you just were to write it as a quotient, it's really easy to do. You just write it as x squared over what? E to the 3x, it's infinity over infinity, it's ready to roll for L'Hopital. So some of them are ready to rock and roll. I want you to go do number 1, just to make sure you have that long process down before you leave. There's a key name, beware of it. Like, this would be really tempting to go, what did you do next? And then you do it next, and then what did you do next? And then you do it. Try it and then go check yours.
Are you just doing the front side tonight?
No, this is our homework today.
All 16.
They're not all long though. Alexa, how many were you able to do without this lesson? That was 5 maybe?
Yeah, but I only started like 3 of them.
She was in it hard time and she said, can I start? I said, you should be able to figure out about 5. And like the subtraction ones, like number 8, that's a quick one. There's no such thing as adding 0.
I'm telling you, my brain isn't fried.
What?
You can't take the natural log of 0. You can approach 0 from the right hand side and it's infinity.
There you go.
Natural log of 0 doesn't make sense.
Boom.
Natural log of 0 would be like answering the question e to what power equals 0. That's a silly question. Right, John?
Sure.
If you're like not knowing why, that's a silly question. You might, big writers, like my key took up a lot of pages. I'm a medium-sized writer. I did show all the steps, but you might want to go to a separate sheet. I'll put the key up for this one in the middle. The first 4 are the hard ones, and then they kind of go all over the place. They'll go easy, medium, hard, hard, super easy. Oh, I don't even need to do anything. The answer's 2. That's why there's that little plus on there.
And then you go.
I don't write this stupid simple
Yes.
I don't know, that's what I thought.
There's no way for people to write that one out now and pick it up.
They sell it Tuesday.
Not feeling football practice.
I'm selling it Tuesday.
This could take me a bit to like this.
I'm donating.
Scrimmage,
It's not illegal though.
Anthony Club.
You know what? Why? I'm going to Africa and dropping it off where you got it.
Oh, the video.
Alright, I'm gonna put the answer up. And I'm gonna have you score yours actually. Guys, give me a sec. Shh. Everybody, be quiet. All people. It's super important for you guys to know how these are scored and where points come from. Because the right answer, honestly, there's lots of answers that are 1 and E and like E squared. Like, those are very common. So, shh. Here's how you should score it. Are you ready? Usually these are worth 6 or 7 points. Okay? First of all, you should have natural logged both sides. Okay? You should have started with the correct process. If you don't, you're out 6 of 6 right away. Even if you stumble upon the right answer. Next, I took the natural log of both sides. I did show that these can swap. You might have gone right to here. Or you might have brought this out front as you went. But either way, you should have been taking a limit as x approaches 0 from the right of x squared times ln x. Are we there? Okay, that's where you should be. That is actually 0 times negative infinity. It's a product, which isn't good. It's an indeterminate form, but all I need to do is tweak it a little bit. So I chose to leave the more complicated function on top. Did you guys make that choice? ln x over 1 over x squared. This would be a point over here for the negative infinity over infinity. I want you to know what form you're getting. To me, it's important. I don't want you just assuming, oh, I get to L'Hopital. It's important for you to know that the natural log of x goes to negative infinity as x approaches 0 from the right. That's an important concept. All right. So then you need to tell me when you're launching L'Hopital. So if you launched and did not tell me, all right, I need that's a point. That you do it at the correct spot with the correct indeterminate form. The derivative of the top is 1 over x. And I think I heard Mandy say she got a negative 2 over x cubed. I was like, oh, yep, something's right, because you should have been saying that. All right? Now you have a complex fraction, so you got to do a little algebra. Multiply by a reciprocal. I ended up with a negative x squared over 2. Now, if you had like an x to the 4th over 2 and then got a 0, you're going to lose a point for some of the... You can stumble upon the right answers pretty with some mistakes. Does that make sense? So I do correct like every step of it. I hate it. I hate correcting these. So your answer isn't 0 though. Agreed? That's what the natural log of y equals. You need to undo that. So our answer is 1. How do we do?
Yes.
Got it? They get tricky.
Hey, Laroon.
Yes.
So I've been writing like every step. I skip a step, like I figure I do it 2 steps in one go.
Yeah, that's the I won't take points after that.
But what I was wondering is I put like ln is equal to it, but I put where the LH starts on the over the y. Should I put it over the limit?
What are you talking about? Like in mine, what's different?
So like you put the LH here, I have it saying ln is equal to, and then the LH is above the y.
Oh, that's okay.
That's okay?
Yeah. Actually, it's kind of safe to keep writing
That's what I've
LNY
been
so
doing.
you don't forget to undo it.
That's what I've been doing.
It's a lot of LNY,
I just
LNY.
Well,
wanna
it
make
helps
sure
me
it
gather my
wouldn't
thoughts
cause me
before I start to
cost
write,
me.
so I don't make basic mistakes.
So it is actually YC. What?